So let's move on to another surface, the cone, right? So here's again the equation, z squared over c squared equals x squared over a squared plus y squared over b squared, right? So here we have a nice circular cone because a and b are equal to each other, right? It's not so important that c, or what c is, to make it circular or not. Right? C definitely does have an effect on the graph, though. So let's start by seeing what C does to the graph. Right? So if we increase C, we can see that it makes the cone a lot tighter. Right? The edges of the cone get our increase a lot faster. So I guess you could say the slope of the cone is a lot higher now, right? If we increase C. But if we decrease C, we can flatten the cone out quite a bit. So let's bring C up maybe to about here. All right. So what happens when we mess with A and B? Well, it's pretty much the exact same thing that happens with the ellipsoid, right? Because if now we're going to just think of Z as staying still, like if we imagine that Z squared over C squared here, imagine that it's just a constant. So it'll give what's called a level of this, or a trace, as they're called in the textbook. Right. We'll see that we just get x squared over a squared plus y squared over b squared equals some constant. And that's a circle if a and b are the same. If they're not, we get, of course, an ellipse. Right? So if we increase a, again, it stretches the cone in the x direction. And likewise, if we increase b, it stretches the cone in the y direction. Right? Okay, so the cones are not too bad to understand. The point of the cone, though, is you always have this sort of double cone here. If you only want one half of the cone, either the top part of the cone or the bottom part, you have to solve this equation here for z, and then so when you do that, you have to take a square root. The positive square root will give you the top part, and the negative square root gives you the bottom.